Hi everyone, this is Romain Chiapinelli from Altitude R&D, and I will show you the new feature of the Simulator-in-Hardware, or SIH, within PX4. And so I added the propeller model from University of Illinois, Urbana-Champaign. And so we have the thrust T and the torque Q function of the advance ratio J through CT and CP. And I decided to model the CT as a second order polynomial fit of J, and CP as a second order polynomial fit of J as well. And this is implemented in PX4 SIH for fixed wing, VTOL, pusher, and tail seater. And now I will show you what I did, and you can do the same if you have a different propeller. So you can get your propeller in the database, and I use the APC 8 inches times 6 inches pitch. And so that's this data, and I just copy paste that in the spreadsheet. And now we want to know what CT0, CT1, and CT2. It will be the same for CP, but I won't do it. So let's select that, insert, chart. And we have the chart, and now we go to customize, Siri. We add a trend line, and the trend line is actually polynomial of degree 2. And as a label, we use the equation. And that's it. Can we make that smaller? Okay, so we see it's a good fit. And now we have 3 numbers, and that's actually this 0.131, it's CT0, this 4.16 times 10 power minus 3 is CT1, and this minus 0.146 is CT2. And actually, CT0 is always bigger than 0, and CT2 is always smaller than 0. And so if we go in the vehicle configuration, this is SIHF. And so we have CT0, 131, CT1, 0.004, and CT2, minus 0.146, which is what we have here. Now, you'll also need to give the diameter, that's 8 inches. And we'll need to give the maximum RPM, which is, in this case, I chose 9,000 RPM. Usually, you can find a maximum RPM by the motor manufacturer, like T-Motor or KDE or something like that. And now, if we go to the Mavlink console, Simulator SIH status, we see that we're running the fixed wing vehicle, and we're using the dynamic model for the propeller model. So that's the model from UIUC. So the diameter is converted to meters. We have 9,000 RPM, and we have a maximum thrust of 6.15 Newton. And the whole point of this model is that as we're flying faster, the thrust decreases. It goes down to 5.5 Newton at 10 meters per second and 3.3 at 20 meters per second. That's it.